let's say that you have a 4 by 4 matrix and you want to find the determinant. One of the ways that we can do this, as we've discovered, is by using the fourth row as our coefficients, and that's going to give us, let's say, determinant of A equals the first entry in that row, which is 0, times the determinant of, once we cross out this row and this column, the determinant of this matrix. Well, it doesn't matter what the determinant of this matrix is because we're going to multiply it by 0. We discovered this in the previous couple of videos where the coefficients, if the coefficients are 0, we end up with 0 values here for all of the terms that have 0 as a factor. So in this case, I'm going to have 0 times a determinant plus 0 times a determinant plus 0 times a determinant. And then I need to figure out what sign goes here. But after that, I can just figure out what the determinant is. See, I need to multiply it by -1 because that's the value in this position here. I'll go back and figure out what the sign is in just a minute. And I'm going to have a determinant here. So I do need to figure this one out, but I don't care about these ones here because I'm just going to multiply them by 0 anyway. So here I'm going to have plus or minus -1 times the determinant of, and what is that determinant? Let's see, I'm going to cross out row 4 and column 4. And so I'm left with this determinant here, or this matrix here, this submatrix. And so what I want, let me rewrite this a little bit. What I want is the determinant of the matrix, 1, 2, 1, 0, 2, -1, 0, 0, -2. Let's figure out the sign. I'm going to have, let's use the formula, -1 to the power of. And the power is going to be, since I'm in row 4, column 4, I have a 4 plus 4, which is 8. And since -1 to an even number is, to an even power is positive, I just end up with -1 times this determinant. 0, 2, -1, 0, 0, -2. Okay? So that's it. All I need to do now is figure out the determinant of this 3 by 3 matrix. Well, that is going to be, that's that same negative sign from there. Let's pick a column and row that will make our work easy, and that looks to me, there's a lot of zeros in row 3 rather, so let's use row 3. And I'm going to have here coefficients of, put a big set of parentheses around this, 0 times some determinant, and 0 times some determinant, and then a sign, which we'll figure out in a minute, times -2 times some determinant. Well, again, I don't care what these determinants are because they're going to be multiplied by 0. And in fact, it doesn't matter what the sign here is because I'm just going to multiply, I'm just going to add 0 plus 0 or 0 minus 0. I'm going to get 0 either way. So what I'm left with is this negative times some sign times -2 times a determinant. Let's go back and figure out the sign. Here I'm looking for the sign that goes in this position. It comes from this -2 here. I'm in row 3, column 3, so that's a 3 plus 3, which is 6. So I have -1 to the 6th power. Again, that's positive, so I have a negative from above times a -2 times the determinant of the numbers, the matrix made up of the numbers that are left over when I cross out row 3, column 3, because I'm working with this -2 here. And that determinant is 1, 2, 0, 2. And when I compute that determinant, let's see, I've got a positive 2 here. And I get 1 times 2 minus 2 times 0. 1 times 2 is 2 minus 0, and I get 4. So that's the determinant using the techniques that we've already talked about. But let's talk a little bit about what just happened. I found the determinant using this row as my row of coefficients that was almost all zeros. And when I found the determinant of the submatrix, I also had a row that was almost all zeros. In fact, in the third one, where I crossed out when I was working with this submatrix, which is what I had down here, nope, sorry, down here, I had a zero in that one too. So one thing to point out before I go any farther is that what I've been working with here is what we call an upper triangular matrix. You'll notice that all of the non-zero values here are in this triangle. And the values below, some of these can be zeros, but what's important is that all of the values in the bottom triangle here, those are all zeros. This is called an upper triangular matrix because all the non-zero values are in the upper half. Okay, it's more than half, but the upper part of the rectangle, the square. The upper part is where all the non-zero values are. We say that we've talked about a little bit about this before, but this particular arrangement of values here is called the diagonal. This is the diagonal of this matrix. And all the values below those values are zeros. Those values can be zero, and the values above them can be zero, but the values below them must be zero in order for us to call this an upper triangular matrix. We can also have a lower triangular matrix in which all of the values below the diagonal, there's my diagonal, are non-zero, and all the values above the diagonal are zeros. So this would be a lower triangular matrix, and these values might be, I don't know, I'll make some up here. 7, 2, 1, 0, 2, 2, negative 3. So in this case, all of the values, here's my diagonal, I'll do that in blue again. There's my diagonal. All of the values below the diagonal are non-zero. Well, the definition is that all the values above the diagonal are 0. So here I have a lower triangular matrix because all the values, any non-zero value must be on the diagonal below it. For an upper triangular matrix, any non-zero values must be on the diagonal or above it. Okay, so that's what an upper and lower triangular matrix is. And that's what we were working with here. So when we did our computations, we ended up only having to compute one 3x3 matrix, sorry, one 3x3 determinant, and that 3x3 determinant came from this submatrix. When we did that, we only had to end up computing one 2x2 determinant because of all the zeros in the row above. So if a matrix is in this particular form, then it's actually really pretty easy to find the determinant of that matrix. Even more impressive, even more interesting, and even more useful, I think, is the fact that we're going to take, to find this determinant, we're going to take this single value that we need to find the minor for this value, put it here and find this determinant. We're going to multiply this number by this determinant. Let me write that down. So we're going to have -1 times some determinant. And what that determinant will be is -2 times some other determinant, because we don't need these ones, right? If we're using these as coefficients, they're just going to zero out the determinants that, or the terms that we would use them in. So we need to multiply our first entry here using the -1. All of these are zeros. We have -1 times some determinant, and that determinant is going to be -2 times some determinant, even smaller determinant, so -2 times some other determinant. And then the determinant that we find here is going to be the one with this 4x4 matrix, so it's going to be 2 times, we don't need to use the value that we find here because of the 0, and we're going to multiply this 0. 2 times 0 is just going to disappear. So we'll have 2 times And when we find the determinant of a 2 by 2 matrix, we take the product of these two. So I'm going to say 2 times 1. And so what I've got here is -1 times -2 times 2 times 1. And that is -1 times -2 times 2 times 1. And it doesn't even matter what these values are. That determinant can be found simply by multiplying those numbers together. And -1 times -2 times 2 times 1 is 4. And that is what I got when I did it the longer way. What's equally interesting, I think, is that it doesn't matter if you're working with an upper triangular or a lower triangular matrix. Let's call this one B. The determinant of B, because it's in a triangular form, is simply the product of the numbers on the diagonal. So here I'm going to have 6 times 5, which is 30, times 7, which is 210. It's a much bigger value here. I used slightly larger numbers in my matrix. But the point is that if the matrix is in either upper or lower triangular form, you don't have any computation to do other than to multiply these values together and ignore all the other entries.